Hey guys, okay, so today y'all are gonna learn about an exponential function and how to graph it. So on your notes, go ahead and write this down. The exponential function is going to be y equals a times b to the x power. So your x is now in an exponent, hence the exponential form. So again, exponential functions are defined by an equation of the form of y equals a times b to the x power. A is still kind of like your a in quadratic, so it's still going to be the coefficient of this number here. This b is going to be a number. It's going to be called your base. If your base is greater than 1, this is going to be called an exponential growth because it would be increasing. And if your b is less than 1, this is going to be called an exponential decay because your b is decreasing. So let's look at those two on our Desmos graphing calculator. So if I typed in y equals, let's say my base is 2 to the x power. This is an example of something that is going to be exponential growth. Okay, you'll notice it kind of starts out at a flat line and then it increases, and it's increasing exponentially. So this is exponential growth. Versus something like exponential decay would be y equals 1/2 to the x power. This blue one is exponential decay. So it starts out up top and then it declines exponentially and then again has this flat line. So those are going to be the two different ones that you learned today. We're going to start out pretty basic for graphing our exponential functions. Then you have this asymptote. It is a line which the graph gets close to, but it is never ever going to touch it or cross it. So y'all go ahead and write that down. Make sure you know it is a line which the graph gets close to, but never touches or crosses it. Another thing to note is that your asymptote is going to be the constant at the end of the function. So there's nothing here right now, but it would have a plus or minus, a constant here, and that is going to be your asymptote. So the plus or minus constant at the end here. And again, sorry, I'm writing this on my computer, but this is the constant at the end for your plus or minus. So if we go back to our Desmos, you'll notice that my red or my blue doesn't have a constant at the end, so it'd be like saying +0, and that is my asymptote. So if I zoomed in, especially to like really close in on this blue one, you'll see it's getting super close to the x-axis, which is 0, but it's never, ever, ever going to touch it. It's like getting super exponentially close, and I know sometimes it looks like it touches it, but when you zoom in, you're going to realize it will literally never touch the x-axis because that is the definition of an asymptote. Okay, so here is how you're going to graph it. All right, so we are going to, number one, without a calculator, I need you to classify it as growth or decay. This is y equals 2x. So since b is greater than 1, it is going to be exponential growth. So we are going to circle growth here. And then the other thing that we can focus on without a calculator is our asymptote. Our asymptote is always going to be an equation. So on your notes, I would also write that the asymptote is always going to be y equals the constant, again, so a number here. And so I would put that, I'm just putting the pound sign for number. So y equals a number. It is going to be a equation though, because remember it's a line. So just kind of like your axis of symmetry from quadratics, asymptotes are lines. So we need y equals this time. There is no constant here, which means that our asymptote is going to be y equals 0. So I know that it's growth. I know my asymptote is going to be y equals 0. Then I get to make my table of values by using this and my calculator. So I'm going to go to my calculator. In my table, I'm going to type in the function, which is y equals 2 to the x power. I'm going to start at 0 and go by 7. I'm just going to click OK a bunch of times. And I'm going to get the first couple of values, or even if you want to get the negative value to show that 1/2, 1/4 is a little bit hard to graph. but we're going to copy down these values. So we've got negative 1, 1/2, 0, 1, 1, 2, and 2, 4. Let's start there. So I'm going to fill out a table. So I'm going to do negative 1, 0, 1, 2, and if I can fit 3, I will. So I've got 1/2, and then I forgot already. 0 is 1, 1 is 2, and 2 is 4. Okay, and then 3, let's get that really fast, is 8. Okay, and then you're going to graph these. So you're going to make sure, I'm just zoomed in a little bit. So negative 1 is going to be 1/2, so it's going to be right here. And then 0, 1, there's our y-intercept for your table of characteristics over here. 1, 2, and 2, 4, and then 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and here's the important thing is to know that because my asymptote we said was y equals 0, it is never going to touch this x-axis. This is the asymptote. So it'll get really close to it, and you can even see that from your table of values. If you go up into the negatives, they're just getting smaller and smaller fractions. I am never actually going to hit 0. So what my exponential growth looks like is this, and obviously I'm doing that with my fingers, so sorry that it's a little bit touching the x-axis. Actually, you know what? I'm gonna fix that for us. So you wanna make sure that you start out not touching it, and then it's going to connect the dots, which I did a terrible job at, but you get the point. Okay, so that is our exponential decay, or exponential growth, excuse me. It has arrows on both sides. The domain, hopefully you guys have seen, is going to be negative infinity to positive infinity. Your range is always going to depend on your asymptote. So because this is going up for forever, it's exponential growth and going up for forever, I'm going to go to a positive infinity for my range, but I'm never, ever going to get below 0, and so that is why your range is going to be 0 to infinity. I'm also never going to have a bracket here because remember that it's never going to touch the asymptote, so it's never going to actually touch 0 here. The y-intercept here is going to be 0, 1. I can see that from my table of values, and then I'm done. Okay, so on number 2 here, hopefully you realize that this is going to be exponential decay. Again, that is because this is a fraction that is less than 1, so it is 1/4. Our asymptote is once again y equals 0 because there's no constant out to the side. And then we can do the rest in our calculator. I'm not going to do this one fully for you guys, but you're going to plug in the 1/4 for your base to the x power. It's still at a 16, so I'm going to start it back at 0. I like to start at 0 for these exponentials. And then see that I'm actually getting smaller, so I'll start at the -4 and then go down from there, but these decimals are going to be pretty hard to graph. So we will start out at -216, -1/4, 0 was 1, and then 1/4. Whoops, 0 was 1. And then 1 was your 1/4. So when you graph this, I know I can't fit a 16 up here, but the -1/4 is going to be right here. And then 0, 1 is going to be right here. And then like 1/4, and it's just going to get super, super close to my y-axis. So -216 is all the way up here and then is going down like this. That's a terrible line again. But you want to start out, you want to show that you're starting out all the way up where the -216 would be, and then you're hitting it as best as you can through there, and then kind of leveling out, again, not supposed to be touching the x-axis because that's where our asymptote is. The domain is once again -infinity to positive infinity. And our range is actually still 0 to infinity because I'm still going up for forever, even though I'm going up This way, it's still going up for forever, and my y-intercept, you can see from the table here, is 0, 1. So you guys are doing that for all of your graphs here. You're just kind of exploring it with the graphs, and then read the subplans about what to do next, and I will see you guys on Monday.